Oh, you know I didn't.
No, it shouldn't be. But
Okay,
so you guys have this that kind of shows up in two spots, but the idea is like the same. Whenever you're looking for the maximum or minimum of something, that's an application of the derivative, right? The first derivative gives you the max or minimum. So what we want to do is we want to find p prime of x. Okay, that should be your goal.
So for the next part,
What's p prime? Go for it.
Negative 10x plus 340.
Good. Okay. So once you guys have your derivative, when you're trying to find the maximum or minimum, what do you need to set it equal to? 0. Okay. Set equal to 0. Okay. So. Right. Now we want to solve for s. So minus 340 divided by negative 10. So x is going to equal 34. So what this tells you guys is that to make the maximum profit, Cold Stone has to sell 34 ice cream cones. Now, to figure out the actual profit, what do you have to plug it back into? Original, yeah.
I got it.
Oh, sure.
Now it's in the calculator.
Yep.
Which I don't have.
Okay. So go back to original for this one. Did he never get it back?
No.
He was right next to it too. If this comes out to be something like negative or weird, it's because I made up the number. So sorry. It's fine. Thanks, Caroline.
How are you? Good. Can you just scroll up to see what I missed?
Oh, yeah, this is the first one.
I got 4,500.
4,580?
Yeah. Oh, no.
No?
No.
Is this one? I don't have anything right now.
Do you have your own?
I might have my my gray one up here. You can use that. Oh yes, here, you can use this one. This is literally all I have. They're all being used for everybody else's Regents exam. Sorry. I mean, you guys don't really need a calculator for too much stuff like this kind of stuff. I mean, you can just do, but hopefully it comes down to it. Is this one good for you guys? Yeah. Okay, super. Today we're doing all application problems. So if you were absent the other day, you have to watch the video. Sorry, we won't have time to do everything. All right, let's see. All right, here's the next one.
All right.
Yeah.
Stress would be all right.
What was that for? I wasn't there.
Go like into another goal. Name the goal.
Oh, sorry.
Yeah, I thought you said last year.
I know I did a lot.
You did, yeah. So I think around $3,000.
Right, you break. Right, break.
This one's too. at the bottom of my
Velocity is first derivative plus force. Acceleration is second derivative.
Okay. So then this is easy, it just kind of refreshes your memories of like, that's what.
Sorry,
Think more like calculus stuff. Like, you're right, it is. But, will everybody eat pizza?
Yeah.
Yeah.
One slice per course.
You don't like pizza?
No, I said one slice.
Oh.
Ryan says get out of his country, so get out of the ocean.
I am not sure.
Ocean's still not a country though, right?
There you go, that's right. It's a body of water.
Steven, we think alike. That's wrong.
Do we need to put like units
One
for the velocity? Or-
No.
Isn't one F prime and one F double prime?
Yeah.
That's it?
Yeah.
Which one?
F prime, velocity first derivative, acceleration second.
And then you plug in the 3, 2.
Do you guys think 24 cut is big enough, or should I go for like a 24 and a 12?
24 is probably.
24 is.
I'm only gonna have like one piece.
Yeah, 24 is.
2 max.
Yeah.
You sure?
Yeah.
Okay.
I didn't.
We just call quick in order.
Is it negative 7 and then negative 32?
Good, I just made it up, so I don't really know quite a bit.
Wait, what happened?
Wait, check the zero.
You do the derivative and plug it into the derivative. For the velocity. Yeah.
And then for the acceleration, I think the second derivative and plug 3 into the second derivative.
You're not gonna.
Okay, Mr. Know-it-all.
I think you just made them all.
Good. Would I be able to order a 24 cut cheese pizza and have it delivered to the high school? Yeah, whenever it's quicker to you.
But then we can't.
Thanks so much. Can I get your credit card? I don't know. Yep. Okay, that's perfect. That's okay. Okay, that's all right. No problem. Yeah.
Oh, they all want to go?
Delivery, yep. Yep. Yep.
No, don't ever text me again. I did.
401
Okay, Rob, what was that?
828.
What's it
160.
say? It's wet. Does it make a noise?
Yeah, can we do $3? Perfect. Awesome. Thank you so much. Appreciate it. Okay, guys. Okay, sorry, guys. All right. So velocity is first derivative. Kayla, that was good. You knew that. So negative 32t plus 29. Okay. So now when you guys do your first derivative, if you want it after 3 seconds, you're gonna plug the 3 in for the t. You got negative 67? Good. So this is gonna be decreasing, right, with the negative, that's what that means? Good. What about the acceleration? What would you guys use here?
You use the second derivative, but it's just negative 32.
Right, so it's going to be just negative 32. It's constant acceleration because there's nowhere to plug it in.
Say the negative 32 squared was there. What if you get negative 32 t?
Okay.
No, okay.
So if you had a t to the left when you do second derivative, you plug it in.
You plug times 2. But it means acceleration.
Wait, I'm talking first or second.
Okay, well, say squared for the double side, you do 32 times 2, which is
4, yeah. And then you have t.
So then you use 4 times 4.
Yes.
Okay, sorry.
Yeah. So this is
Okay,
but
yeah.
okay.
Does it turn off?
Okay, let me get it on this
Stay
one.
lit forever?
Oh, this won't be long, should I go on?
I'm actually going to Google a question with this one to make sure it makes sense.
So we're taking the course with me tomorrow?
Yep.
Is that box gonna be here, Miss Carter?
Her back.
11 o'clock. 11.
No.
Tomorrow.
12.
It is 12? Oh. Why did you
Hi guys. I fell asleep, that's why.
Yeah, I gotta find a good one for you guys. So.
I said no one, so I wasn't feeling, I was so Was it me? Hey, is anybody going to the concert?
I might be.
You are? I might be. I might be too. Are you going to the concert?
I might be.
Are you sorry people that are who would sleep on Tuesday?
Are you going to the parade tomorrow?
You are? I have a second part.
Okay, here you go.
Oh, I know I'm not gonna get that from
Guys, okay, make sure you can It's not close. Okay, so this one is very, very, very similar to what you guys have. Make sure, oh, sorry. I don't know if I can even make it bigger. I think if I make it bigger, it'll.
If you,
Yeah, I'm sorry.
told me about taking on three parallel cushions.
Part
Five
of
on
the
feet and then this is what dimensions will maximize total area.
So 3 parts?
Yeah, separate.
Is there like a name for this?
Optimizing. Like what I did to find this, if anybody needs extra questions, like I just Googled in like optimizing fence problem calculus, optimizing area fence problem. This stuff comes up. So if you need more practice on your own, you want to make sure you're doing right, that's what I would Google, optimizing fence problem calculus. It's gonna be a general one like this, not anything with like a cylinder. Okay, it'll be fenced. Right, 3 sections. Okay. So the first thing you want to do here is get yourself a rectangle. Right. 3 parallel partitions means that it's going to be into like 3 sections. Right, so you want to make it so it's like 3 sections of this. So what you guys want to do is you want to think first, if you're talking about maximizing the area and doing something with this 500 feet of fencing. Just so you guys kind of think about it more mathematically, vertical things are like the Y. Like if you think about the Y axis, it goes up and down. So I would make these all Y. And then what could you make? Could you make this? X. Yeah, I could. X. Great. Okay. Yeah, if you did, so if you guys did something like this, like you did X, 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 that's okay too. Just at the end, you have to take into account that you let it be like 1 section. And if it asks you, the dimensions for the largest possible area, yeah, yours will just be set up a little different. You should get the same answer.
Yeah. Just a little detail about this, just so I don't forget. Paige did get a tassel in her Bergman, in her task thing, and she told me to ask you about
Okay,
it.
I think I wrote on that. It might have fell out in the box or something.
Okay.
So I'll give you one of the answers, but
That's fine.
just like, you know. Okay, so the first thing you guys want to take care of is talking about using 500 feet of fencing to create that. So what does this part represent? Perimeter. This is your perimeter. Good. Okay, it's like, it's kind of like the perimeter, but using like each, I shouldn't say perimeter, it's like the actually like each section, if you guys use the length of each thing. So how would you guys get that?
2x.
Good, 2x plus 4y equals 500.
So we want to find the minimum of factors.
Yeah. So now when you guys have this out in here, what you want to do, okay, is you want to get one variable so that we can actually solve this thing. So we want to solve for y. How would you get y by itself? So we have 500 minus 2x all over 4 equals y. That part okay for you guys? Okay. Now, since we're trying to optimize the area equals, well, if you were doing like the area of this, how would we represent it? X, Y, good, okay. Like length times width, right? Length times width. Okay, so now if you guys know that y equals this, what we're going to do is make a substitution, right? We're going to get rid of this part, put in the y in its spot. So now when you guys simplify this out, we'll get 500x minus 2x squared over 4 is the area. Now, keep in mind, like, this might help you guys when you think about what you need to accomplish. Anytime we're doing something with like the maximum, the greatest value, here we're optimizing, what type of derivative is this? Is it second derivative? Are you integrating first derivative?
First derivative.
First derivative, good. So whenever you're looking for the place that you're going to get the maximum or greatest thing, it's where the first derivative equals 0. What you want to do is take your first derivative, you want to set it equal to 0. Okay, so let's get our first derivative here. What do you guys want to use? You can use Hodikai if you want. If you want to pull out a 1/4 in the front.
See, I did it a different way, and I had divided by 2 instead of dividing by 4. like earlier in the problem. Like if you move it around different, it's a lot easier.
Did you solve for X instead? You solve for X instead? Oh, that's okay. You can do that too. So then at the end, we should get the same numbers, just our subs are backwards. It's okay. Okay. So now, if you guys wanted to do Hody high, you can. So if you want to bring out a 1/4, you can too. So Ho, you did the D high. Yeah, I think I might do it doesn't matter. Well, if you do minus the high D Ho, like your high times the D Ho would just give you 0, right, over 16. So it doesn't work out too bad either way. And those can cancel, you get, yeah, so you'll still have the 1/4. Okay. So what we need to do is take your first derivative and set it to 0. We want to find what our value of x is going to be that's going to optimize this.
What did you just do?
I just took the final derivative of this.
You did Hody high?
So Ho, here is this derivative at the top.
Okay.
Okay, minus, all right, so if you think about the high D Ho, what's the derivative of 4? Nothing, so
Oh,
this
okay.
will be 0. Then over Ho, so 16. Right, so when you take your derivative and set it to 0, you just get 500 minus 4x. Okay, so minus your 500. Right, so 5 by -4. So 125. Yep, good. Did you guys get 125 as the value of x? Okay. So now once you get that, you just want to go back up, okay, to where you have like the restraint that it has to equal to 500. So if you know x is the 125, okay, our restraint was this part, the 500. So if I put 125 in here for x, we want to solve it out. So 2 times 125 is going to give us 250 plus 4y equals 500. So minus 250.
So we take that and we put it back into.
Yeah, because you want to find the x and the y. So 250 divided by 4. 250 divided by 4. 62.5. Now, did you get the same stuff? So then your y, oh gosh, sorry, 62.5 should equal to y. So your y should be 62.5. The x was 125. I'm going to give you guys another one of these for you guys to do.
Yeah, so like after we get the 125.
Okay, so once you guys get your 125, is that where you need to?
Yeah.
Okay, so once you get the 125, that's just one value, so you need to get the y. So what you're going to do is plug it back in.
You plug it into the like y
This right here.
Oh.
Because, well, look, you can't plug it into this, because if you only know one of them, can you get there? No, you don't have enough stuff. So,
plug it into the other one.
this right here?
No, the other one.
Oh, yeah, you can do it in
Yeah,
this.
that's what
Oh,
I
yeah,
thought.
that's okay, sorry. I didn't even think
I
about
like that
that.
one better.
This would be way easier, because it's already solved for you. No, that's totally fine. Yeah, you could do that, sorry. Yeah, so if you did your 125 into this, you should still get 62.5. That's just commodity. Let me give you guys another one that you can kind of like start on your own. Kyle, did you get to do that same thing when you did it your way too? Okay, perfect. Let me know when I can get rid of this.
62.515.
Yep, you got it. Okay, let's do another one of these. Oh, I don't want that.
South Carolina when I got there.
They did?
Yeah.
Good.
He was 21.
So nuts. Like,
Understand.
me either.
Oh, I know so badly what I got.
I know.
I know. No, she doesn't know.
Yeah, and she had to go to Galway.
Oh, really?
Last year
Yeah.
was Stillwater.
Yeah, she's not very happy. Poor Miss Duncan.
Like Friday, I think. Wait, what was that?
She said the absolute latest Monday.
Wait, she's on half.
She had to go to LA.
What are you talking about? She had to go up to Duncan and go to Galway to
Let's see. Sorry, I want an easier one for you guys.
That was the easiest one. I finished the 50 questions in 10 minutes.
Oh, wait, wait, oh my god, it was so easy.
So remembering what the answer was for me, because I don't remember what I did last year. And it was obviously learned and done. Yeah, most of it was common knowledge, so like what is the...
Right, like, you know,
Yeah, I was
Alright, thank you so much.
I'm gonna go get it for you.
Thank you, don't get off Another question, just save you one piece, because I haven't eaten yet. Alright, can I just make this up? Alright, so let's see, we are gonna do find the maximum area.
Was pretty much the same.
Yes.
You just
Oh,
had
yeah,
to
it was.
use the political question.
You just had to write, yeah.
Instead of conservative. So that's what.
The whole time I was studying, like the first one, no, the first time, and then I wrote the second one.
Yeah.
I forgot which one was which, so I just thought of Michael and Sam. And I was like, what is Michael? I'm like, oh, he doesn't like, he uses like against like the marriage equality thing. I was like, alright, he's done.
Well, and one of the questions was like, what would be more conservative, and then everything that was liberal was all the other options, and the only option that was different than all the other ones was like, no marriage equality or something.
Yeah, and the abortion thing and death penalty, they're all different.
Well, yeah, I know, but there was a multiple choice question, pretty much wanted to know. It was, I don't remember what it was, but it was the only one that was different.
Thank you. There's some like, you can pass this over there too.
I just don't want to draw the picture. I don't either.
Okay, so we have to make a rectangle. Right, so if you want 2 pens, you want like 2 persons, like 2 pens.
Oh, you know what? I thought you meant pen. Like in my pen,
Like if it was a farm, like 10. Start with that if you need help drawing some picture.
Is it XXXXYY? I did it the other way. I did
Or
Y.
Here, you can do that. Here, grab food, get food. You already doing nothing? Just save me one, my order quick.
I call that better.
It doesn't matter.
Guys, wrong good?
I thought you said 10 when you read it.
Sorry, can you go call it something else? Let me know.
Do it like a pig thing, like.
So it's always gonna be A equals
Where did you order this from?
Yeah, because that's the formula for area of like a rectangle, right? Like we know. No.
Larry. It is.
It doesn't look like it's
No, it doesn't look good at all. Is that good or bad?
No, I just did.
I'm not going to lie. No, that's
I
okay.
haven't had them for dinner. I was talking about that. I don't have to really share with them, something.
Ryan,
Oh my God,
that's so good.
So
Where
good.
love
It's
your way.
so good. Larry probably made it. That's my guess.
Are you
Yeah,
gonna
it was probably Larry that made it.
Kaylee, they stole your pen.
Because the pizza guy doesn't go until 3. That's totally probably.
The dough even tastes good.
Yeah, the guy doesn't. Sorry, guys.
No. Fine, it's good.
Sorry.
You're welcome. You're welcome.
Oh my god, yeah.
Okay, so when you guys, the first thing you want to do here is make sure you take into account like how much fence you have to use. So when you do all the fence, how do we represent that? Yep, so 2x plus 3y equals 8. Awesome, good, okay. Well, now you have to get things in terms, here's your 2 things that you're trying to do. You have this to handle, right, this is like constraints, so you can only use 800 feet of fencing, but what we have to find is the area, which is x times y. So you need to get one variable. That's like your goal, so then you can optimize the area. So we want to figure out, you could, like Matt and Kyle did the opposite. They solved it for x instead of y. You could solve it for either one. You just have to solve it for one letter. Okay, so solve one letter.
Oh, really?
All right, Nicole, you need help later.
No, I was just gonna ask you, always right?
Well, for what you're doing, yeah, it doesn't have to be. It can say optimize the volume, but I'm trying to keep things like at the end of the minute.
That's true. Yeah, it's just a number. Can I do this one? Oh, I didn't do, okay, never mind. No.
There's that one.
What do I do after I got done?
Did you get the ribbon? Yeah. Good, good. It's pretty good.
What did you go over before I got here?
So basically, like, since if we take the 1/3 out in front, can't we just like take the derivative at the top and put it over 3?
Right.
Yep.
Did you guys, you solve it for y, did you get this? I think that's what most of you guys did, solve for y. Okay. So you gotta put it back in. Alright, bring this thing through. Now, if you're here, don't forget what you're trying to do. Okay, you need to optimize the area. So what derivatives do you need to take?
First.
Both. Is that part okay?
I used to round to 7.
Whoa.
You're looking for area, not the dimension.
I'll be
Go ahead. I got. Go ahead.
I'll be in Mexico because
I
Okay, so area you guys should have.
again.
It's 4x over 3. Okay, good. So, this is your A prime. How do you find the x, like the point of the optimization? That's a 0. Good. You guys should have a ton of these problems too in your notes, because like we did that whole, remember we did a project on them?
Yeah.
So hopefully you kept it good. I think we did optimization for a couple days too. We should have 800 minus 4F.
Like, also then be careful.
I hate mixing up with my stomach.
What did you guys get for your F? 200, super okay.
I don't know.
Just make sure, once you get the F, plug it back in, get the Y.
133.32.
So, go back to where you have the constraint. You're doing it? Good. That'll put you at 800 minus 400 over 3. 433. Yeah. 133.3. Do we feel better about this after you've done 2 of them?
Yes.
They're kind of the same over and over again.
It's the ground floor.
Yeah.
So you know how we can have like over 3? Can you just like ignore that sometimes? I always forget to do that. I always have the same answer.
Yeah, you could totally, it's like bringing 1/3 out.
Alright.
Yeah.
Because I always forget.
That's okay. Alright, so you have one of those, it's very similar, so if you guys are studying tonight, make sure you get similar stuff there. Then we have,
The very next one.
No.
Oh my god, are you okay? I get you like, don't do it. Then you did it. Just that one parent class, I thought you were going to put shower or dishwasher or sewer?
I'm getting that with my.
You getting that dishwasher?
Not going along.
Sarah, see who pays more. See what pays more.
what do you have to do?
For what?
Pays more. No, I texted Maribel and she didn't answer it. She read it and she didn't answer it. I will text it at 9:45 this morning. Yeah, this morning. Maybe she thought I was like, she worked till 1, so she has like 2.
What? Remember like some story about
The what?
Fresh Shepherd? Yeah.
It does, it's like $12 an hour.
Yeah, I get $12.80 an hour. So, I'm gonna be making $3.75 a week. If I work 8 to 1, but I might be working 8 to 5.
Alright, so here's your next one. This one's pretty tough. It's a cone problem on related rates. So again, if you guys are someone who needs extra stuff, if you want to Google related rates, cone. They're just long, like.
I wanna write this problem, but I don't think I write down and leave it.
Yeah, I'm literally gonna write the whole thing down. I have
I don't know, but I feel like if you condense it.
Yeah.
Hold on.
Yeah. If I work 8 to 5, I'd make $3,000.
How'd you go from 375 to?
Because what job is infrastructure?
It's my uncle's business, and I'm working in the office, and I'm either working 8 to 1 or 8 to 5. If I work 8 to 1, I'll make $375 a week, but if I work 8 to 5, I make $3,000 a week.
You need any more help? That's like more than making a month here.
Me too. Let me know when you guys are done with your
I'm gonna
rating.
need that though if I'm gonna be a teacher.
Yeah, it's great. I need that for a job.
It makes more on my summer job than I do.
I used to waitress for so long. It makes so much money.
Yeah.
My still keeps going. Alright, so hopefully, yes, I'm gonna give you guys all this stuff. So here's our little cone. The height of 10 feet. The height of the cone is 10. The top rim is the circle with a radius of 4. being pumped into the tank at a rate of 2 cubic feet per minute. What is the rate of change of the water depth? All right, in feet when the depth is 5. Okay, so I'm going to give you guys, what are they trying to do? Are you trying to find like area, volume, like talking about filling the cone with water? So here's your volume of a cone formula. So you guys will get this. Here's your clue in this stuff. You guys always, when you're dealing with a cone, you need to create a proportion. This should be like your first step. So in the proportion, okay, if you need to write step 1 is to make proportion. You're confused already?
No, we're good now.
Oh, all right. I didn't do anything. So with the proportion, okay, you guys want to take the radius and the height of the cone. So the radius of the cone over the height of the cone. Okay. And then it's going to be equal to, Brian, do you know what's going on here? I know. I'm telling you, the final's hard. Like, if you're not studying and paying attention, like, it's not going to be good. And then this one's going to be the radius of the water and the height of the water. Okay. You're going to keep your R and H here because we're going to have to use that at the end. All right, so this is what your proportion needs to look like.
Where do you get that formula?
Yes, you're going to get this one. I'm not going to give you this.
Well, yeah, no, not
you'll
that.
get this one.
Yeah.
Okay. Right. So now, when you guys go to plug things in, okay, we want to plug in the radius of our cone. So just make sure if they give you the diameter, cut it in half with the radius. So you know that. All right. So 4 over 10 equals R over H. You with me so far? Okay. Now, I think one of the toughest parts in here is that you guys have to realize like what you're looking for in the problem. So here they're asking you guys, let's see.
They're asking for depth.
The depth, yes. What is the depth like? Is that like the radius or the height? The height. Okay, good. So they give you guys that the depth is 5 feet. Okay, depth represents the height. So your goal in here is, yes, good. We want to get this all H's. Okay, because we don't know anything about the radius. We just know that the depth is going to be at 5 at some point.
We would want to solve for R.
Yes. Good job, Olivia. Perfect.
I actually do it to see it because
So we make the H on the bottom 5? No.
Okay, so you want to solve for R. That way, we can get rid of the R up here and make them all H's. This part, guys, I think this is honestly the hardest stuff. Because once you have it subbed in, you're taking the derivative and it's not terrible. This is the worst part. Okay, so we're going to cross multiply. 4H equals 10R. And we want to solve for R. Okay. If you want to reduce this and make it, 2/5, totally fine. So R equals 2/5 H. Okay, so by doing this, we can now use
And
the
if it's
volume.
asking for like the radius, you have to solve for H.
Exactly, and like I said, I'm trying to do the same type that you're getting tomorrow, so it'll look like very similar to this. Okay, so let's use our volume now. We have 1/3 pi. Now instead of the R squared, we're going to put in 2/5 H squared. Good job. Yep. Okay. H squared times H.
I always forget the square.
No.
25 over H.
Are we going to be given the formula?
Yep. Well, if you were listening over there, you'd know. You said earlier.
Yeah.
Hey.
Okay. So just watch out as you're distributing to both things here, all 3 things.
You're on the same page.
So we should have 4 over 75 pi H cubed. Okay. And you guys just think it all in terms of one letter? Okay. So this is looking good. Now, again, if anytime you're trying to find, like, this is another application of how fast things are changing, which is which is a derivative application. So what we want to do is find the derivative of this. But when you guys take the derivative with related rates, what is it in terms of? Remember? Good, dt, so in terms of time. So when we take the derivative of v, how do you guys write that? Good job. v dt. Nice. All right.
So you have to take the after you do that, you take the derivative of that.
Yep.
Thing. Okay.
Yep. I'll give you guys another one to try on your own too, with a little bit more after we go through this one. Okay.
What are the ones where you like write out if we knew what the HBT was?
Oh, okay. We can do that. So let's. All right.
Don't we know what each?
Well, let's see in here. Do we know what if water is being pumped into the tank at a rate of 2 cubic feet per minute? What does that represent? Okay, so you're being pumped into the tank, filling the dVdt. You're how fast you're filling the tank. That's the volume.
Whenever cubic is always volume.
Yeah. Oh, that's a good guess. Right. Cubic is for volume. If it was square, it would be like area. So dVdt is this.
Wait, volume is always cubic.
If you guys want to, we can do that first if you want.
Yeah, that's what I was thinking.
No, that's okay. So then, what is the height?
DHT.
Okay. Well, anytime it says rate of something, the rate part is the dt. So it says the rate of the change of the water depth. What does that part represent? That's dHdt. Good. So dHdt, we don't know. This is what we're looking for.
So do we know each?
Okay. Well, let's see.
Wait, I thought we had to look for dVdt over there. Like, I thought we were going
Oh, yeah, we do. They want us to like identify stuff first. So we're gonna go back to that in a second. What is the H? What part of here is the H? 5. You're just looking for the depth being 5, so that's just regular H. So H. No, that's fine. We can do this first. I should have did this. All right. So now we can go back over here. So we take the derivative of v, dVdt.
But don't we already have that?
Yeah, we're gonna sub everything in after.
Yeah. I'm just like writing everything out.
We have to take the derivative of that problem. Yeah, but we're gonna plug everything we know back in after.
Okay, so when we take the derivative over here, it's like using power rule, right? So 3 times 4 is going to be 12. If you want to do, did anybody do this instead? No? Okay, we could do 12 then if you want. What do you, does this make sense to you or am I confusing you? Okay. Alright, so 3 times 4 is 12 over 75 pi h to the what? Squared. Now, when we took the derivative, good. Who said that? Eamon? Sean? No? Nate? Somewhere? Nate, good job. So dH dt.
So it's not like it's 4,
Okay.
so wait, I have a question. So it's not like it's 4 to the third power, it's 4 times 3?
Right, because well, you're doing power rule. So like, if I gave you like this, 2x cubed, and I said take the derivative. Isn't it 6x squared?
Yeah.
That's what we're doing.
Okay.
Okay. Nate, sorry, bud. I wasn't looking. I just heard yelling. You're usually quiet. You always just know what I'm hearing, don't say. Okay, so now those of you guys who were concerned that we had stuff, now's our time. We can plug it in. So we know dVdt is 2.
I thought they were saying that 2 is the derivative. That's why I was confused. That's why we selected.
Okay. We got our pi. We know the h is 5. We don't know dHdt. Okay, so this is what we're looking for. Okay, so let's simplify it here. 5 squared is 25. Can we do this?
Sure.
Yeah, so you get 4 pi.
Okay, so we should have 4 pi dH dt. Yep. Alright, good. And divide by 4 pi.
Oh, I did it right.
Okay. So dH dt, let's see. I mean, if you guys left it in terms of pi, that's fine. If you actually like, you know, did 2 over 4 pi, that's okay. Oh, Chunk, thank you. That's fine.
I think it's 1.5.
Yeah, it's 1.5.
Good. 1.57. So it's going to be increasing at a rate. The height's going to be increasing at a rate of 1.57. Centimeters, that's what it is. All right. Do you guys want one of those by yourself?
I don't think I'd be able to do it by myself, honestly.
Well, I mean, we could start it.
Yeah.
You don't have a lot of questions left. The application stuff is just long. You have like this and then
How many
2 more.
are actually on the test?
27 or 30. Like one of them's got like 4 parts, so
Yeah.
it's like the same kind over and over. Okay. All right. So let me get you guys another one here. I'm literally giving you the same exact things that are on your test. Oh, that one's really hard because that has tough cones. Oh wait, nope, this is fine. Okay.
Yeah, I don't remember the last time I had dinner with my family. Everyone always wants to know about My dad wants to make family.
Okay, good. Yeah, this is perfect. Okay.
My mom just compared me to a dog. My mom just compared me to a dog.
Larry.
She's like, did you breeding? No, I'm getting a dog anyway. Swear to God. Isn't that funny? My mom's getting a dog now when I'm leaving for college.
You're getting a dog?
Yeah.
It's because she's gonna be alone.
I don't care. She's selfish. She is selfish, Carolyn. I've been asking her for years. Literally. I'm getting a dog. Yeah. What kind? Boston Terrier. I've literally been asking for like. I know. That's why. Yeah.
I know, so I get to go.
I've literally been asking for years, like begged my parents for years to give me a puppy, and now I'm leaving and she's getting a dog.
They're replacing you.
Yeah, I know. Fair. But Boston Terrier. They're so cute. Yeah. I mean, I prefer like a bigger dog. My mom doesn't like big dogs. Yeah.
Did you get it?
Probably 3 dogs. Actually, I got a stray dog first.
I'd be bigger than everyone. Yeah.
Or it's just a suggestion, but we don't take our final.
1,000
Do you
want your college credit?
Final.
No.
I think we tried to do that last year.
Yeah, I think we can get, if we get 500 retweets, can our final be to draw a pony?
Listen, if it was my own final, I wouldn't care, but like, you have to get college credit.
How about you walk us through the entire test?
Ooh, no one will know.
I'm basically doing that right now.
I know, I'm just saying, on the test, there's different numbers.
She might have to walk us through this question on the board tomorrow.
You have 2 points, or test finals.
What time's the trig region? Oh, in the morning.
In the morning, like 8 to 12.
Tomorrow?
Yeah, so right after it. That might be like 15 minutes late. Do you want to start at 12:30 tomorrow? Because that'd be better for you.
Yeah.
Yeah, is it the whole class?
Is everybody?
Who's missing?
No one. I thank you, Olivia.
I said it to Snow.
Aaron.
That's gonna be everybody.
Yeah.
Okay. Is 12:30 okay for you guys?
Yeah.
I mean, if you want to come earlier and chill in here and study, it's okay too, but. Yeah, that's fine.
Hey guys in the back.
What time is it?
Do you guys want to do 12:30? Is that okay? She said. Just then that way I don't have questions from them. That might work out better.
How do you think, your drink is gonna do?
I'm gonna have to make that do awesome, like really, really good.
I can't see the board. I don't know where.
You get that every year.
Yeah, like I don't know why they show up. Like,
Because I don't,
oh, you don't put people over it.
they're not like, hey, you know what, we're looking past for like, let's just make it even harder. Oh, so that's what they're doing, like, oh, don't worry, you can get them through it. I don't want to kill myself anymore trying to get kids to add subtract correctly.
I love how it goes. There's a feature for
Okay, so there's a little cone.
It came like a 4 already played.
Bill, let you know. It's 14. Okay, so if you're someone who likes to identify stuff first, we can absolutely do that. What is the VDC? Do we know that? Okay, and it's leaking. Be careful. The other one we were filling. So how do you represent that? Negative 2. Good. Okay. All right. They're asking us the rate at which the depth of the water in the tank is changing. So what is this part? Good job. All right. We don't know what this is. Okay. What do we know what the H is?
Yes.
Okay. 14. You're close. We want to do it at that point though.
What?
I don't understand these problems.
Alright, so now your first step, you know what you guys can do, those of you guys who get confused with what's what? Once you draw your picture and fill this in, you don't use any of this stuff to come up with your other curve. You know what I mean? It's always like what's what. So you're never using this to come up with anything over here.
It's always VDC.
Yep. Alright, so you have to make yourself your proportion. Okay, just do your first step. Alright, radius of the cone, height of the cone, and then R over H over here. So put your 5, 14 in. Okay, good. Now, when you guys do your cross multiply, we get 5H equals 14R. So think about what you want to find. You know the H over here, so we need to get this away, right? We want to make them all H's. So we need to solve for R to do that.
How would you know the answer is supposed to be? Okay, because I got a really weird number, I don't know what it is.
Did you use 5 over 14H for R? Okay. So once you guys get your R, now you can sub in up in the top 5H over 14. Sorry, 5H. Oh my god. 5H. Oh my gosh, what am I doing? I did not write 5H over 14 squared H. There we go. So now we gotta simplify this all out. Bless you. I need you to book everything.
Did you pick up? Amen. It was hello.
I didn't hear it.
196.
We got 14. 196.
Okay, so if we keep rewriting some stuff. We need to.
Is it H to the 3rd or no?
Yep, it's an H to the 3rd. I'm just gonna clean like all this stuff up in it. So if we take, we have 25 pi. Oh, actually, why did you like try to cross multiply here?
No, I didn't know what to do with the 1/3.
We're just gonna be multiplying, like. all the top, all the bottom.
Yeah, I just don't know what,
Then you can 98.
what the heck?
I'm just stopping.
Guys, we're just small like fractions, like literally like,
Top times top, bottom times bottom.
yeah.
What was your 78 and bottom?
That's alright, I'm getting confused.
Okay.
So keep going.
Alright, if it's, so 1 times 25, here we got 25 pi, h cubed, and then on the bottom, 3 times 196.
588.
Okay, so this is what our volume equals. Now, we have to find the derivative. Okay, so you're taking like the power rule. This is that power rule stuff. Okay, so when you guys take your derivative,
So will the bottom still go to 0?
good, so take your 3, bring it out in front. That's good, so 3 times 25, we can do 75.
78.
Good, yep.
Pi.
8
Squared.
yeah. Work, perfect.
But I don't understand how you just leave that 588 there now. Because you still
Okay, if you took, okay, let's do an easier one. If I had,
Because in the last one, didn't we get rid of the bottom?
well, I think it's because I canceled, like, things were reducing. Like, you could reduce fractions. Think about it like this, if you had something like this, right? Okay, you would take, bring it to the front, right?
Yeah, but then in like these ones earlier, when we did that, we just got rid of the 4.
Yeah, that's because we're using a whole different rule here.
Oh,
Yeah,
so how, so you only use Bodhi if there's 2 terms, right?
Right. And like here, you gotta be careful because in that problem, you were doing everything related to being with x, right? Here, you're doing everything in terms of t, so we have to write like d. See how we do the dt after? That's why we can't like do something else. Alright. So once you enter here, then plug everything in.
However, got
So we have negative 2.
Okay, so after you take the derivative, then you start plugging in all the stuff.
Yep, plug in all the stuff. Okay. 588. Alright, your 8 was 6 squared, which is good, 36. You want to do that one graph, we can.
Yeah, I don't know. Do you do 36 times 75?
Yeah.
Yeah.
Okay, so we get 225?
Oh, yeah, that works. I just want to show everything so I don't want to you guys.
I have this weird number.
What did you get?
Okay, so
I got negative 400.
2,500, that's good.
I got negative 98 pi.
Wait, 2,000.
36 times 75.
Right? I have that all written down.
When you move the 3 to the front, I just reduced it to
No, that's okay.
25 over 190.
I was confused with the stuff and that's okay. So but no, you can totally do that. I think you now have that.
Yes.
Oh, you know what? It reduces.
There we go, good. Now, if you guys want to do any kind of like reducing of things, we totally can. Are we okay right here? Okay, does anybody know how to get rid of this? By what? Reciprocal, good. Okay, so.
Yeah, you're right. You were
Divided by.
Why did I write my time?
Yes. Is that what you got? Did you guys get that? You got that, Sean? Karen, was that what you got instead of
I
your?
left it pi.
Oh, you didn't use pi?
Well, I like left it in terms of pi.
Oh, no, that's okay. See if you did the same thing.
Negative 49 over 52.
I didn't get 1.
No, I didn't get that.
You didn't get this?
I got 123.
I got
That's what I got. Did you add an extra 0 in
I had an extra 0, let's see.
I got that too.
How do you think?
I simplified. I don't know. Why did you simplify
Yeah,
it this far?
Because we were confused about why.
I simplified it and then it just screwed me all up because
Let's,
I got my numbers mixed up with the other.
because if you take,
You get 225 over 49 for 2,700 over.
I have negative 5, 29.
oh my god, wait a second.
Yeah, I ended up with that, and then I took a 5, and it came out to.
Let's look and see here.
Yeah, Miss Carmen, I don't know what you did. Sorry.
Oh, yeah, that's okay. We do.
I don't understand how we got.
Yelling makes you go faster.
I literally put that into the calculator, and it comes out as -1.
Oh, wait, you did negative 98 over 225 pi?
Yeah.
See, if you put parentheses around, that's what I did. And it works. Yeah, because I think it messes up 10 dash. See if now if it works. Works now?
Yeah, because look at I did 5.
Stupid 10 dash.
I did 588 divided by.
Oh, yeah.
And then I got that.
Okay, you're right. So 36.
So just make sure that you put your little parentheses. But
I wouldn't.
Eamon, what did you do back there?
I got negative 1.37.
Wait, that's the same thing you guys got, negative 1.2.
No, we got
I got 1.
-1.
That's the same thing that we.
Correct.
He said 1 point.
Yeah.
Yeah, that's what we.
Oh, it's because of the parentheses and then. Eamon, it's because if you put it in the calculator.
Even you gotta use parentheses around the 225.
Sorry.
Well, then you're.
I'm still eating.
We simplify that.
I figured it was.
Are you okay with it? Yeah,
Okay, that's negative 1,000 divided by 2.
5 down now.
Every time I'm like something upstairs, like this.
Well, it's the same answer, right?
If you leave it flat, I told you guys that you
Somebody
have
used
to
to
simplify
buy
it.
it.
Yeah.
And like.
Either to disregard or to the.
Well, yeah, you didn't have to work bleed before. I didn't go. Well, like Saturday.
Whoa. Nate, how are you feeling? Aaron.
Last night.
Have you ever been in Corky's backyard? Okay. Here's like. Aaron, I'll do it. There's this tree that is forever white and Paige and Nate were gonna race at the same time. So Nate he starts running, he looks like the little boy from Little Rascals running with the firefighter stuff. It was
Yeah.
that's all I thought of.
And
then Paige won.
It was like,
Matoda.
like when you do negative 98 divided by, you don't put parentheses.
Oh my god, one paper
It
left.
divides and
Oh
then
my God,
multiplies
you
by
guys do.
something. It doesn't like keep it together.
I don't know what you're being told, but.
What?
Wait, I think, what did you do that?
I just put Robert.
Last time on high school. Money and we were trying to do like, she wanted to like divide it by half and multiply it with the calculator.
I don't think I have any other things you guys think of either.
That's it right there. It's doing this divided by 900. And then doing yeah, you have to group. We need not see if you do that group, like literally 9.5.
I had a cabbage.
And that.
Okay.
Alright. Again, so if you guys need more with these, feel free. Not with this.
I don't know, but I was up at the study before.
Even this point.
I could study about how yourself. I know their number. One is with your, or like.
You know, I completely every single one that I spoke to. You know, you can do it.
What?
You know, you can do it, yeah, just.
And then they were all. Each side. What are the odds that
Have you ever like done any studying by yourself?
I'm putting every single one.
Okay.
Yeah.
It's just, I didn't know how to do those last problems.
Last
I've been
couple.
doing that all.
We were recording.
He does his own thing.
What are the
Wait, what game was it? Aaron. Every time I put up my
Out of 1 to 5. You said how much?
everything.
I didn't hit you very hard.
I'm gonna like take notes.
Yeah. And I wrote like really good notes for you guys with this like in your review.
Okay.
Like I wrote like how you find like all your asymptotes, what has to happen, like.
What I'm trying to find is finishing algebra for this.
Yeah.
Okay, good. So especially after
So
this,
is
like.
perfect because I didn't want to do it yesterday or the day before, but I want to like do it when I do it.
Right.
So that I'm recording.
And you guys have deadlines too to worry about, so. All right, so let's do, actually, sorry, do you need more time to write anything? No, you're good, okay. So let's go through each of these kind of like step by step with what everything is, okay? The first thing you guys need to do is find the critical point. So when you guys are doing critical points, if you want to make notes for yourselves or kind of write things down, right? The critical points are where f prime is equal to 0 or undefined. Right, the bottom position, sorry. Alright, so first thing we need to do then, what do you guys think we need to find? F prime, great, okay.
45?
Yep, you got it. So here's your original, let's do 45, we gotta figure out what the derivative is.
Wouldn't that be asymptote at 2?
We'll get to that, I want to just like one step at a time. I had to write something here.
Is it just when the derivative is undefined or when the original also?
Derivative.
Derivative?
Okay, so we should be using Cody High. And then once you guys kind of set it up, make sure you are careful, you simplify everything, distribute the negative. Okay, so here's your first derivative. So what we want to see is first, for your critical point, right, what will make this equal to 0 and where it's undefined. So where is this undefined? Where's the bottom going to be 0? 2, good. Okay, so it's undefined. Yeah, 2. Okay, and the other critical point is going to be where this thing would equal 0. So if you need to take it and set it equal to 0. Okay, think of it like this. Cross multiply, this whole bottom part's going away. And then we're going to need to do our factoring. Yep, good. So x equals 5, x equals -1. Okay, so these are all your critical points at x equals 2, x equals 5, and x equals -1. This is all where certain things are going to be happening, special points are. So the next thing we want to do is test for where things are increasing and decreasing. So what you guys had to do back in the day was make yourself a little kind of picture, right? And we want to use these critical points, -1, 2, and 5. Just to kind of help us out a little bit, does anybody know what's happening at 2? Not a whole. An asymptote, it's a vertical asymptote. Good. And we'll kind of talk about that a little bit more why, but just for the purpose of our lecture, it can help. Okay, so just test increasing and decreasing. Yep. Increasing, decreasing. You want to pick type numbers between the intervals. Sean, where do we plug them back in?
The original. No.
I
thought we always plug it back in the original.
Well, that's the point. Yeah, it is to find the y. It's to find the other part. If they add, like when we do the max and min, that's going to be your point.
Never
Who smelled that? All year. You. Okay, so let's pick stuff.
-2.
Okay, let's try -2.
What?
How about, what do you guys want to plug in here?
1.
That works.
Between
3?
-1 and 2 is
3, and then 7? Sounds good.
Wow.
Okay. All right. Remember, we don't care what the actual physical number is. You're looking for, is it positive or is it negative? The number that you get when you plug these in. Okay, so make sure we are going back into your first derivative. Right here. I showed you, remember we did our little show thing too? You guys needed to? Like we did -2 show as x, right? That way it was a little bit easier when you guys had to go plug things in. Okay. So we did, I can't remember what it was. I'm putting parentheses around things because, like, PEMDAS gets messy with a lot of this, so just be careful your stuff. And then the bottom was the x minus 2.
Yeah.
Oh, okay.
Positive?
Oh my god.
Might be because of the PEMDAS. Like,
Oh, I didn't put an extra parenthesis?
Yeah, because
yeah, because it thinks to do this.
yeah, because it's squares.
You guys can always like type it all in, but alright, so I got a positive, good, Nicole. Okay, so let's do the same thing with 1.
If you hit 1 step,
I'm
and
gonna
then
do
hit
the
7
second right now.
and then hit 2nd, enter. Oh wait, just kidding, hold on, click clear. Click clear again. Oh,
No,
no.
you can't say you can scroll up and click.
Oh, and go
something.
back.
Yeah.
Oh, yeah. Oh my gosh.
I'm sorry, I didn't know how it worked.
No, it's okay. It's okay.
You can still do that if you keep scrolling up and you hit enter. It saves you some time.
So much time, right? Does that work?
And it's a negative.
It's -8, I guess.
It is -8?
Yeah.
Perfect. Okay. Good. So this was negative. What did you guys get between
-8 still.
Yeah,
I got negative.
negative again?
And then positive? Okay, good.
I don't know if this is that how we're supposed to do it? This is not the case.
No, because we're gonna get rid of that. Get rid of that one.
You don't allow that.
No, we're done. There you go. Good.
So it's increasing negative infinity and negative 4.
All right, so let's see. So now when you guys do your increasing, decreasing, we're going to be increasing from negative infinity to good. Yep. Yep. 5 to 3. And decreasing, okay, we're going from -1 to 2.
And then 2 to 5.
Yep, then 2 to, oh, sorry, you need 2 to 5. Good. Why would you guys not want to do from like -1 to 5?
Because there's an asymptote.
Good, because there's an asymptote. We want to kind of make sure we're
Wait, you know my dad's what is this answer here?
with equal to 0. Okay. All right. Now, then you guys are asked about the extrema is the next thing I think you're asking for. Okay. If you want to like write a little note for you guys, the relative max happens when f prime changes from positive to negative. Right, there's a relative min when f prime changes from negative to positive. So if you guys aren't sure, once you read this and you kind of think about what it's showing you, a max happens when you're going from something increasing to decreasing, right? That's going to be a max. All right, this one's going from negative to positive. We're going to get a min. That makes sense when you think about it like that. So now, in our picture, okay, we're going to grab something a little more in depth in a little bit, but this kind of helps you guys. You're going from positive, right? We're increasing until you get to -1, and then we're going to be decreasing. So, is this going to be a maximum or minimum? This is a max. Okay, so you want to get the maximum, like the actual coordinate.
So you plug in the original.
Yes, Sean. Good job. Okay, so we have -1 to get your y coordinate. Go into the original. Okay, so go back up.
So this is for the max,
Oh wait, that's way too much. Yep.
so the x is negative, then
Good. So go back to your original.
one still?
I got -2. Should be -2.
Wait, yes, -2. I didn't let it compare very well.
Okay, so get the maximum value. Okay, see how it goes increasing to decreasing? Okay, so it's happening at these critical points. Those critical points are where
They
things
will
happen.
actually be moved in a whole lot.
Yeah, in real life, yes.
Oh, okay.
Yeah, this is just kind of getting us a sketch of what like parts of it look like.
Right.
And we're gonna have to get.
So relative extrema is the maximum min. Which do you? So what do you have? What do you use for the second derivative?
That's for points of inflection and concavity. You're not gonna have to do that. Okay, because otherwise it becomes super like ridiculously young. Okay. Because it's honestly the same process kind of thing. So we're just doing this one. Okay. Now in here, going down and then back up. So the min is 5. Yep. 5 what? Let's see. Let's go to our original and put 5 in. 3 over and 10. 10. I got 10. Court, you put it back into your original problem? 5 squared is 25 plus 5 is 30. 30 divided by 5 minus 2 is 3. Right, 7. Yeah. How'd you put it in? Yeah, it's probably why it's from that. If you're ever dividing by more than one thing, you gotta put parentheses.
This is the last problem.
Most of the answers.
Alright, so that's for max and min. You guys also, this problem, you have to identify all the asymptotes. On your little sheet that I gave you guys, I said do the relative and absolute. I'm getting rid of the absolute. Okay, so you don't have to do that. Just worry about this part. Okay, so, hi Kyle. Okay, so to do your asymptote, okay, so I wrote little notes for you guys on your own sheets too. How do you tell where the vertical asymptote is?
When the bottom
Bottom equal to 0, but in your original, right? In okay, so what in our original made the bottom equal to 0? 2. Yep, 2 still works. Yeah.
So when it makes it undefined?
Yeah.
Okay.
Yeah. Okay. So our vertical asymptote is at x equals 2, so at the bottom equals 0. Now for your horizontal asymptote, okay, you guys have to test out your degrees. So again, if you guys need to, I wrote like really kind of specific stuff in here if you want to go back and look through all of them. But we want to look at the degree of the exponent. Okay, so way back up in your original one. Okay, if your degree of the denominator is bigger than the numerator, let me write all this down for you. Okay. Good. Okay, good. So if the degree of the denominator is greater than the numerator, it equals 0. If the degree denominator equals the numerator, good. Okay. If the degree of the numerator is greater than the denominator, nope. No horizontal asymptote.
Then what is that for?
Oh, you're thinking of limits.
Limit?
Yeah, you're thinking of limits. You're taking the limit as
But
like
it's still the same as
approaches.
the numerator. Alright.
Okay. Unless the degree is exactly one more, you have a slant asymptote. Or synthetic if I'm there.
So this one has a slant one?
Okay, so yeah, let's kind of identify this now. So we decided that we have a vertical asymptote. For the horizontal asymptote, the degree of the top is exactly one more than the degree of the bottom. So what kind of asymptote do we have? Slant, yeah. Okay, so we have no horizontal asymptote, but we do have a slant.
Oh my god.
Who is doing that and might hurt you?
Please tell me you're mom.
Alright, so for the slant asymptote, we have to use synthetic or long division. Okay, I gave you guys something nice where you can use synthetic. Okay, so let me rewrite the original problem. I can't even do. Does anybody have it? X squared
plus 5 over x minus 2.
Thanks. I don't keep scrolling up. Okay. So if you guys are going to figure out your equation of the slant asymptote, it's been a while since we did this. Okay. Anybody remember what has to go on the outside?
Oh no.
Or do you want to use long or synthetic?
long.
You're going to synthetic.
I don't know.
I'd like long and synthetic.
Okay, alright, I'm going to use synthetic. I hate long division. Let's see if we get the same thing. Nope. If you use synthetic, it's very short. Okay. If you're going to use synthetic division, all you do is what's underneath, you're going to change signs to 2. Like positive 2. Now, underneath, you want to make sure it goes in order, like a standard form. So you have an x squared, so we have a 1x squared, then 0, then perfect. Good. Okay, so all you do with synthetic is you bring down the first one, just 1, and then you multiply 2 times 1 is 2, add, so this is going to give us a 2,
Times 2 is
4, yep, and then 1. Perfect. Okay, nice. Now, if you did synthetic division, you're like, oh, done. Okay, you don't use the remainder. Yep, you got it. Okay, so we don't use this. And then the other part goes in order, so it's like the x and the constant. So the equation of the slant asymptote is going to be y equals x plus 2, or like 1x plus 2. Did you guys get the same thing as long division?
Yeah. Yeah.
And again, you can do whatever way you want. This is just faster, so yeah. Would you like long division?
So you don't use the 9?
Nope, you don't use the remainder.
Do you use
So you don't ever use the last thing, so you're always going to use the other two. Did you get, like when you use your long division, you still have the same kind of idea? Like you have a remainder of 9, so, okay, perfect. So then Sarah, you'll have like the x already up there. We don't have it with synthetic, so it just goes in order like the x and the number.
Gotcha.
Okay. So this is going to be your equation of the slant asymptote. Sorry, we're almost done. I have one more big question for you guys.
Okay.
Okay, so after you do all this stuff, okay, all you're going to be doing is graphing it. And on your graph, like you guys have graphs, like physical paper, but what I'm looking forward to see is that to make sure that you guys put in your asymptotes, like we had the asymptote, vertical asymptote at 2. You guys also had a slant asymptote at x plus 2. So if you started at 2, you went up 1, over 1, something like that. Hi.
I need the test.
Yeah, give me 1 second. Okay. You can come everything out for a sec. Alright, so make sure you guys do both your asymptotes, and you know where you guys got those critical points that you had? Does anybody know what they are at the top of your head?
-1,
2 and 5.
-1, 2, and 5? Okay, good. So where you guys had like your min and max, what was your max point? -1 what? -1, -2, good. And then the 5 was 5, 10, way up here? Okay. Now, it was increasing, right, and then decreasing. And then over here, it was, is it decreasing and then increasing? Can't remember. Yeah, so something like this, I think. Sorry, my paper kind of stopped.
Wouldn't you put the thing, wouldn't you have it go towards the asymptote more?
Yeah, my picture's not like very scaled. You know what I mean? Like this, I think it's supposed to be
Okay.
angled more.
Okay.
Kind of, so.
Okay, I was just making sure.
You know what I mean?
Wait, wait,
Sean, she's not gonna be like this close, who like, your graphs aren't round enough, point size.
No, I'm looking for like, do you guys know where the values are, the important stuff, how to graph the asymptote?
Which one?
The original. You want to see what the original picture looks like. But to like, so like I just made a random graph right now, and I don't know what my original looks like, right? You guys have graphing calculators available to make sure you're really like graphing it nicely. Like I know I had an asymptote, an asymptote here, an asymptote here. I knew I had like that it was increasing then decreasing, right? And it was decreasing then increasing. So this is like the only thing I could think that it would have to look like. You know. So it's probably close if you physically go ahead and graph your original. See if it looks something like this. I'm just looking that you guys hit the big stuff, hit the nice points. You know, am I gonna get a ruler out to see if your curve is perfect? No. I don't really care. Okay, and we're going to let you know.
Top curve on my calculator.
You can't see the top curve. What if you zoom out?
Yeah,
I think it's
Zoom out. If you zoom. It's because that 10 is so high, I think. Right? That's up there.
I think mine's as far as it can go.
Still can't see it.
Wait, what do you hit for zoom out? Zoom through. Yeah, is that it?
No.
Oh, yeah.
Is it?
It looks like
Why
straight line
is it
at first.
wrong?
I don't know. You're very close to
I hit
the.
zoom out and
Oh, no, this is fine.
3.
I thought it was.
Do I hit
just
enter or no?
the-
Oh my god. No, I have a straight line. Dude, I hit like -1 stove X earlier, is that still in?
Oh, yeah.
No.
Oh wait, mine did the same thing. Mine didn't.
Might be the addition of the calculator.
Just random when you do three, and then you put X squared.
This is what it's supposed to look like.
There, what
Yeah,
is zoom one?
No, I just did zoom 3 and then I pressed enter twice.
Yeah. Oh, enter. Oh.
Yeah.
I might just use different calculators to explain it.
Yeah. Wait, what do I put in your calculator?
You guys are like getting brain dead, I'm not even kidding.
No, I just put it in.
My brain is fried.
You guys are all checked out.
Well,
So,
I wouldn't be brain dead if I didn't have to take a government test twice.
No, seriously. I definitely could.
You think that's what we're talking about? She was. Really freaked out.
okay, so now, so now we're gonna do go out.
Spanish? Yeah. I got an E.
I thought you said there was another one.
Well, I'm gonna do one more.
Oh,
What?
ABCD.
Yes. All right. Okay, guys.
Let's take a look on that. 30 minutes.
Alright, this is like the last stuff that you guys did.
What was that 8 in the morning yesterday? What was that 8 in the morning?
yeah.
I was drawing so bad in the physics test yesterday. Like my eyes were watering so much. Do we have to stay for a certain amount of time for you guys to start?
No, I don't think I
Gonna take notes on and then
Yeah,
hurry
I
up.
was done in 45 minutes.
Will you give us the A?
I don't think
Yeah,
we're gonna
give me
be
that.
done within an hour for
Oh,
this test.
alright.
No.
Next year.
I might not be done with questions too within an hour of this test, actually.
I remember
If you guys need to stay for a while, that's okay tomorrow.
Okay.
I have to grade about $1 million integrated algebra this exam, so I'll be here for.
I forgot they were in here. Pre-calc and geometry are in here tomorrow, so.
You guys, okay.
Everything else is just, it's called small, but 2 years ago, I was on size.
Oh, perfect, that's okay. Good, good.
Yeah.
I have a
Bye, Ed.
question.
Wait, did I call him Paul?
No.
You're brain
I'm
dead
brain dead,
too.
I'm brain dead too, I am.
Oh,
Really.
goodness.
Speaking of, Melanie, did I give you yours? Do you have
Yeah.
yours? Courtney, do you have yours?
Yeah, you
Gage
gave
needs
ours
one.
on the last page for John, right?
Oh, yes.
Or no,
Hi.
the day before the last page for him.
Well,
Wait, what do you mean?
Literally has like a score.
Aren't they in the thing?
they are, yeah, but he just fell out or something, which wasn't in there.
Oh, so you guys did it up because you.
Where is it wrote down?
No, check that.
Okay, so the top would be.
Make sure you're not doing volume. A volume's gotta deal a lot with the rotating, because areas is straight, like,
Oh, okay.
top minus bottom.
So the top would be the Y. Right?
Well, the top is gonna, wait, like the 9 part.
Yeah.
Yes, yes,
Or
the
the
9.
minus 9, I meant
Yeah, that's okay, no, that's okay, good. Alright, so give yourself a picture of this. You don't have to, but it might be helpful.
The line, yeah.
Yeah, you're joking down there.
The 9 people
So the
Yeah, 9
9.
is top.
Ghost or Charlie over here.
And then you fill in the shaded area. Okay.
Yep, right here, good.
Well,
So this guy's what it should be looking at.
oh my lord.
I will give you guys your formulas on this stuff, so you just know how to do it. Alright, so, how can you figure out the A and the B? Anybody know?
The points where they cross.
Yes, so you gotta figure out the points where they intersect. You might just know these.
Three negative.
Good, Megan, Nate, was that you back there? Oh, good. -3 and 3.
Good job, Nate.
So I'm gonna hold down that table.
The
I don't know how you're,
would be
I don't know how you're
right?
concentrating over there.
Where you be the B and then -3 the
I said good
A.
job.
Good, so now when you guys do this, you have 3 to -3.
Actually, it was already good.
What's the top? 9 minus x squared. Great, so now just yeah, right?
Negative.
No, like to grade.
When you wrote the line, that was like a Y.
Oh wait, this is y equals 9.
Yeah.
Oh,
And this is the y equals 3.
I don't know.
yeah, that's what I thought it was too.
Oh, sorry.
Y equals 3. But I knew it was 9, so I was like, broke that.
Sorry.
What?
Okay. So now go ahead and do your integration, and we gotta sub everything in.
I didn't hear you.
You don't sub it in.
I want you all to.
Okay, now plug in 3, plug in your -3.
That was like 20.
I know. No, I know. I was kidding. Wow.
Great. I think it.
No, that's right. We have minus. Wait, I have too many minuses.
No, you don't. Oh, yeah. I didn't see the 30.
No, that's right. 36?
Yeah.
No.
Yes.
Yeah.
Number 1, this is still negative. And then you have a negative sign here.
Oh, I forgot the other negative.
Yep, so now, there you go, now it's negative 18. Okay, and then you're subtracting these, right? So it's
0.
No, so you're subtracting, like, these two values. Put your next minus now. Okay, so what's negative? There you go. There we go. Good job. You guys need help with 36.
Tried to do it in my head.
Okay. Alright, units squared, whatever. Alright, that's your area. Now for your next part. Yep, just for the area. You're using, guys, though, the area. You're using the same stuff for each one. Okay, so you're using the exact same, like, functions. Same picture each time, just a different question about it. Okay.
So
But
was
you
that
said
the
you
one
were gonna give us the
that,
formula for this.
the last one was where we had to,
Partition square.
yeah,
Yep.
but it was like off of the line, so we had to, like, it wasn't on the exact thing.
No, I'm
Are
still
we
not
having-
getting 36. Sarah, do you want to know what? It's why like. Are you doing that on page on everything? I just, because this thing I did too, and that's what's being on. You said it all. Like 4.
Wait a minute, this part's not done.
It's gonna be a 2.
You like did the derivative and integrated at the same time. Alright, when you integrate, you add 1 and divide by that number. You like did like the power rule and.
So the 2 that's supposed to be there.
No. Now you should get the right thing, yeah.
Did it x squared minus 9? Still got 36 units.
You will for this. That's fine. I mean, technically you want to do the top right, it's fine. The reason why is like, it's symmetric, so it'll be fine. But if you didn't have something asymmetric, it'd be good.
I will make sure I get it right next time.
Okay, so, alright, here's the next one. Find the volume. Well, find the volume of power.
I should ask him to shark it.
I honestly would probably do it. As long as I do. What?
No, 37.
No, I'm serious.
So the outer wouldn't change from probably, right? No. So, because we're gonna be, but actually, unless you're going around the line. If you're around the line.
We're the same, so I'm not even gonna be there.
Oh,
I need to do this real quick, I don't know.
Are you gonna give us that for me?
Yeah.
I think so.
Yes.
Hi, yeah, this is her. Good, how are you?
Right.
Oh, hi, hi. It's through my school.
Give it to me.
Yeah.
Do we know DNA?
Thank you, bye. The lady from yesterday was so weird, wasn't she?
Yeah.
I've been talking to her for 3 weeks, where I need to fax me the thing, like the invoice, so I could pay you that night. For 3 weeks, I called her like probably 4 times, remind her, that here are our ID numbers. Nothing. And yesterday, when I had to bring my dog to the vet, she finally decided to send it to us, and then was pissed that I didn't have the check that day. But no, I'll give it to you tomorrow. She was a little off. She was a little weird. Yeah, she was weird. There it is, Heidi.
Yeah.
And
Sorry. Like, I'm bringing the check when I'm going to school, sorry. Okay, anyways, sorry about that. So, alright, if you guys revolve this around the x-axis, okay, what's the outer part? 9, good, okay, so we're gonna take 9, yep, squared, minus.
Do we know what the DNA are yet? Is it 3
Yeah,
negative 3?
same thing, yep. So 3, negative 3, got the pi out there. Raise the inner, what was that gonna be?
the x squared.
X squared, good, and we're squaring that. X squared, yep. So same kind of idea, once you guys have it all subbed in, now we're gonna integrate. I think I'm also by the time.
Are we gonna be, for the test, we're not gonna be wrapping around anything other than the,
X-axis or a line, not anything with Y. I didn't teach you guys that.
so wait, are we doing it on the test for over a line?
Yeah, we're gonna review.
Yeah. Thank you. I'm gonna freak out. You guys completed it. I know. Okay, so when you guys do this, I promise, I'm literally reviewing your test with you. So if we do it, it's gonna be on there. I'm not gonna give you guys anything like crazy. So if you've been studying and like kind of doing stuff, this is literally it. I know Kyle wanted the test, this is basically it.
So is that a pi?
Mm-hmm.
Do they?
I would multiply it at the end. Yep, so do all of this stuff out first, okay? Once you guys do your integration, sub it all in. Sorry. Sorry, and at the end do your pi. And then manual escape here. I don't know what sorry, I'm just changing like the numbers.
I don't like
No.
What?
Yeah, I just have to make sure. A lot of the stuff was
Yeah.
And
one.
yeah, oh yeah, you want to try it?
I am sure. You already have it.
Oh, I wrote one of them out, and then the other one I wrote that, I don't know. Yeah, no, I was going to, but I don't know why I did that. Apparently I was thinking, okay, I'll just do it in my head, and then I was just like, oh, I'll write it out.
And then, minus one.
Yeah, I think that's fun. I definitely agree with that.
Did you just
Especially now with the different
Oh,
answers.
oh, wait.
Not just the Yeah, well, they're both the same age, just one negative.
Yeah.
I got 97205 and then a negative.
Oh,
I got -305.
I got 380.
-3 and then.
Which one was it? Yeah.
The first one was positive and then minus a negative and.
yeah, look at that. Okay,
So
and
that's
then,
what
yeah.
I like 305.
Yeah.
Yeah, I was gonna say that again. No, because it's supposed to be 242, but.
And then we can leave it in terms of time. Do you have a different one?
I just hate some things that he does.
And then being rounded and then create everything back.
You took it? Oh, yeah, you took it.
So I can throw all my.
So what?
That's how you know. Yeah, now you're hard. He's getting -81%. Yeah, electric. I literally, I just did it.
Yeah.
Everything at Calc, I've been asked the same question, like over and over. What question? But like,
What am I doing? Now I know I should.
Do you know that answer?
Yeah.
I don't remember you mentioning anything about driving around the line specifically.
I got -415.
This makes me nervous. I don't think anyone's like gone in their packet by themselves to like review anything.
I did for the voice thing. I may have.
I don't need to.
I'm gonna go and watch all the videos.
Listen, in college though, you really can't like,
Slack off.
well, this isn't like real, like your professor doesn't be like, oh, here's your practice, let's like look at each individual question, they're gonna be like, okay, here's the final, like you need to study your entire class.
Yeah, so
Like-
I'll have to teach me.
So we're okay with that.
Yeah, so it's
Like
one
the one
night
you did like the day
before
before
plus
is
one
not
night
like
before.
smart. So like just start looking at things. That's your answer. Alright, so here's your other one. And then Sean, this is your line one.
388.85.
Yeah.
I left it 215, but I have to get ready.
Shit.
That's right.
What do you have to do to get ready? Put on a dress? Yeah.
Come on, ready.
Then you guys need to give yourself a picture, like, to kind of remind you of what things are looking like.
I have mine on the phone there, but they're gonna look at it.
Well, I had your interview done
Like I pro, right?
this week.
The lady didn't tell me she was calling me to get all my information and my calculator website. And I would go in like the morning after service, or no, after CPA. And I was like, oh.
Is it VA again? Is this one like the GA?
Yeah, yep. Sorry, I didn't write that in there. Now this one is a little bit tougher because your radius is not 0. You're not going like just to the x-axis. So this is, I think, probably the toughest idea.
Is this one of those ones where you have to like subtract it?
Yes, Noelle, good job. You're totally right. So if where you're revolving, okay, is on the top, you want to take this minus everything. Because we're looking at the distance from here and the distance from here. Okay. So when you guys think about revolving around this thing, what was taking this, going around, what was the original? This is x squared, and then you had y equals 9. Y equals x squared, y equals 9. Alright, so when you guys are doing your distance of the outer radius, how can we represent the distance here? 11 minus close, not 9. X squared, good.
So it's always wherever the line is minus.
It's a line above, because you want your radius to be positive. So if it's above like this, you just take the rear revolving around and subtract it. If it was below, you have to do the function first, then minus.
So because like you're revolving around a line, it's not y equals 9, it's x squared. That's the outer because it's like flipping around.
Exactly. You're like taking this figure and it's like, think about it, it's like one.
Yeah, I gotcha. Okay. So
Turning.
y x squared now is the outer one.
Exactly. Yep. That's why your picture is really important, like, because it is changing a little bit based on where you're revolving around. Now, with your inner radius, oh, my bad. I'm sorry, just grabbed right. No, it's my bad. I pressed right up there. All right. Now your inner radius. Anybody know how you're gonna represent that one? 11 minus 9.
Oh, I did 9 minus x squared.
All right. So we need to FOIL this. It's gonna be long. 2 squared 4. Hate doing this, all the work. FOIL. Some of these are a little long.
Yeah.
Did you know 11 times 11 was 22?
Yeah.
Is it 117?
Is it? Oh no. Okay, no, go ahead. Oh yeah, why did I get 197? Sorry. 117. No, totally right. Thank you. That would have been a pain in the butt. Okay. So let's check out. Make sure your algebra stuff is all okay. Because otherwise it, throws off everything.
And then it's just like the steps from the
Now it's just literally the same exact thing, okay? Once you guys have it all set up into the formula correctly, it's always like integrating, subbing, that's it. If you don't want to go through this part, we don't have to. If you want to, we can.
Yeah, you want to do it?
Who said that?
Already
For
thinking
you.
sounds about this
I
point.
am behind.
You don't forget the side at the end. And this is like the least irritating.
I really hate putting it in the
I know.
Really, I like it.
You do?
I hate it. I'd rather be able to just do it all myself.
0?
Why is the editing when they used to make it?
I might have typed in there and told her
I don't
not
think so. I feel like that would have made sense.
How do you do the
My grandparents
fractions?
used
So,
Alpha,
30, I have 7, so much.
you for like tomorrow?
no, I don't know right now.
For what?
No.
Well, me and the other exam. I only have mine.
No, it's fine. I'll just put it.
You don't want home?
Yeah, I got 0 again.
Wait, your trade reads is right before
I don't
ours.
even know if I have
Yeah.
the right, oh, I
Okay,
forgot the
so you might need to borrow it.
I printed it.
That's okay, I'll have them back for
Okay.
tomorrow, it's just that right now I have nothing.
No, it's good, like all day.
You'll have it all signed out.
They have signed now, I saw them
I
signing up.
forgot the actual, like, the one.
That's why.
I don't know why.
I like made them do a sign out sheet and I can't even find a sign out sheet.
Oh, no, I completely forgot to integrate.
Oh, you know,
Yeah,
that's why you would've got 0, that makes sense.
Yeah.
Sarah, do you know, like, no.
Wow. Whatever.
Like, the idea is more important. That's okay, that's okay, once you put it, once you put it in.
What'd you get again?
I know.
One zero zero 8 over 5.
I was
made him get
I was
up.
playing Brendan Rice, wanna give him that one?
And then.
You see him play?
Yeah.
What is you tonight? Sound good. Why did you guys want 8
Well, the trade region is before you guys. Yeah, so like I put Proctor there, and then I went back to Proctor, guys.
1 0 1 8
And I'm sorry, do we do that? Yeah, it's a little secure. So like you do this, like, it's like literally the last thing we did after.
I don't know why, I don't remember it.
So, it's like the area, and the area is square, so it's like templates, right? So we all came, so we got our square.
Where's the part this from?
Next part is, imagine that you're making a square in between two functions. This is, well, this is like square, right, before, this is like this X here.
So you just
Like, yeah, it's really exactly the length of the side. It's like if you were building like little big lava, like this plan.
Wait, now, wait, what is that?
Oh, we're doing it.
Don't worry, we're
Oh.
Yay, good, that was great. You guys should be getting 2016 over 5, 5, and then 5.
The answer is always correct. Now I get all my
Totally playing you right
Okay,
now.
like, what if we got keys or like a,
Or, what is it?
Is the answer 4
2 5, and when you don't want it, that's 4.
Yes, you got it. 3 to 5. Okay, last one.
it's literally the same.
Yeah, the last one is 7
That
questions.
helps me get the answer.
I know, last one. You guys are really pulling my teeth here.
No, it's just find the.
Which one are we on, A or D?
Like the 4th one.
Or it's like, like when they're like black little curls, they're like
See my hair? Was straight from the top. My mom was sending me a
0, 1, 6, 5, 5, is that the answer? Why I didn't
Oh, what?
I wish my mom was sending me messages.
Like, definitely work on this. You just share.
oh, I forgot. I saw somebody get up and get it, and I was like, oh, it's paper.
Oh, yeah,
Here's your last one.
no. Actually,
Alright, you guys?
Oh, you go and plug it in, you should go into user, it's just
Yeah, should we get one of those big ones that you lift up the top?
And you should have different flavors, like I think was I sick
We
for
got
that?
fruit one.
Yeah.
Some stores, some, just gonna get some. Yeah.
You're alive.
I don't know, this is kind of like, my square is really staying. Okay. So basically, this is the last thing we did. It says you can imagine taking little like square sections. You know how when you cut like a fruit, like a banana or something, into like little like slices, and you could still put it together to form the whole volume? This is basically what's happening. Yeah, kind of, yeah. So we were going to do little square ones between this to identify if we put lots of little squares throughout this whole thing, what the volume would be. And again, I give you your areas, or give you the formulas for each one. You guys have to know how to use it. So one thing, to find the side of a square, and we know a square's sides are all the same. How could you, this really stinks in here. What's the distance between our two functions? How could we like represent that?
S.
S, good. And how could you find it? The distance between these.
9 minus X.
So
9 minus X squared. Yes, good, awesome.
Either I did guess the S part.
So that was good. So the difference between this, like the distance would be the 9 minus X squared. That'll give you guys the distance between each of these, like the length.
Now is it 9 minus X in parentheses squared, or is it
9 minus X squared, all squared.
all squared?
Yep, so this is S. Now, when you guys are trying to figure this out, our formula, okay, here's 3 to negative 3 still. Okay, to find AX, it's the side squared. So we're going to take 9 minus X squared, all squared. The reason why we're doing like AX equals X squared is because to find the area, that's what this part is, it's like doing every single little area together to create the whole volume. So the area of a square is like length times width, but if it's a square, all the sides are the same. So side times side is side squared. That's kind of what's going on here. Okay. So in this one, we have to take 9 minus X squared.
So this is basically like the normal version of it, except instead of putting it into two different ones, you combine it into square intervals.
Yeah. Yeah.
Basically.
Yep. Yeah, basically.
She ran away the other day. She got home. Allie, she drove her bike all the way down the street. We were sitting at the table, we didn't know where she went.
Did you have after, like, the official recreation?
Up there.
Well, like, what is that?
It just means that when you're integrating, you're using X's. Like for some reason, if I had like Y here, I would use CY. Yeah, it's just to kind of tell your reader what you're integrating. No pi. Nope. And I'll give you guys the formula, so you'll know whether you need pi.
So you don't multiply by pi in this one?
Nope.
No?
You're really doing the same thing with all the integrating subjects. You're done.
There's also
My turn.
And I mean, you guys understand, you don't need to like.
My shelf builder.
I would just, all the answers.
Oh my god, guys, I'm so off today. I wrote, instead of parentheses 3 in the date card, I wrote 3.
Oh, yeah, before, yeah.
That's not even a thing, exactly. That's why you should put it in the calculator, because I'm off today. Sorry guys, I'm not No, I just have a headache. You always have me. Yeah, I'd have to think that's funny. I'm heading back to She went to her mom today. My sister got him. She wants to do this with me. I keep writing it. Do you actually like hurt you? Really? I hate not having mom. Honestly, I hate contacts, and I can't wear them.
I always wonder how people do them. I like yesterday the first time I even put my contacts in. I did it for 3 hours to run and do this thing, and I like didn't want to make that process so bad. Like I really want to rip them off my face, but I can't see.
My mom, so you know how like you wear glasses when you're not supposed to, eventually you're gonna need them. Well, obviously I would be glad because I can see, but I keep getting.
I got mine for headache.
I know, but the thing is now I need them.
Oh, yeah, now you're gonna.
Yeah, I got mine for headache.
No, that's right.
And now
Well, that's because you never worked.
Yeah, I did, I worked for 2 years straight.
I know, you were always, you'd always be like, be like, alright, on the TV.
I don't remember that.
You always.
Do you have like a copy of the
Thanks, Sam.
Sean, I actually haven't.
Wait, what is it with the last round?
Yeah.
Yeah.
Is being, like, it's no, it's actually, I think it works, but they chose to say.
That's not what I got.
Section off the area, like the atrium of the middle school, to floor less.
Good thing I didn't trust you. Like, okay, do you want to like redo it?
No, that's good. Yeah, once you guys are done, this is it, like,
Nope.